Hello students, I am Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I am going to talk about a topic of switchgear and protection subject. This subject is designed for the third year electrical engineering diploma students. So this is the lesson plan. Here I am going to talk about types of faults and their causes in this today's lecture. Now, before going to the detailed topic, just I'm going to show you a picture. The default occur in a substation or power plant in anywhere in any electrical device, then what can happen? I think from this image you can imagine that how much damage or what is the risk for the fault, and if protection is not there, if we cannot solve it with immediate effect, what can happen? It just damage the entire system within few moments. So for that reason, today I'll just give a small overview about the types of faults and their causes. So this is the topic for today's discussion. I already told you that it's nothing but fault and their causes. Now, first, try to understand that what is fault? Fault is a word it used for different purpose, but we are talking about the electrical engineering related fault, the power system fault, and switchgear protection subject related faults. We have to be significant, we have to focus on it that in an electrical power system, a fault or fault current is any abnormal electric current. So fault is basically abnormal electric current. I think it is clear to all of you now that it's the simplest way. I'm just trying to give an overview about the fault. Just try to remember like this. It is an electrical power system. In an electrical power system, a fault, or you can say fault current, is any abnormal electric current. So any abnormal electric current means, abnormal means something which is not normal. So which is not normal means, so in electrical system, voltage current have some specific limit. So if it does not maintain, or if any fault occur, then the normal voltage current flow will change. It will become an abnormal situation. So fault or fault current is any abnormal electric current. Now we have two types of faults in our electrical power system. Number one is symmetrical fault, and number two is unsymmetrical fault. The first one is symmetrical fault, and the second one is unsymmetrical faults. So today I will show you that what are the different types of symmetrical fault, what are the different types of unsymmetrical fault, what is symmetrical fault, and how this occurs in the system. So that part is basically the main focus part for today's lecture. So first we can talk about the symmetrical fault. I think that will be better if you go in some systematic way. That will be help you to understand about the topic that what is symmetrical faults. It is a fault where all phases are affected so that the system remains balanced. So symmetrical fault is a fault where all phases are affected and but the system will remain balanced. It's obviously a fault where all phases affected so that the system remains balanced. So system will be balanced. Okay, so let me talk about this in the next few slides about this topic, about the elaboration of this topic more and more. Now, symmetrical fault. For symmetrical fault, there are very severe faults. This type of faults are very severe faults and occur infrequently. So it is not normally you cannot observe frequently this type of symmetrical fault in the power system. These are also called balance fault. So this symmetrical fault has another name. What is the name? Balance fault. And how many types will find this type of faults? Two types. Okay. So what are the two types? One is LLLG, line to ground fault, and second one is line to line fault. So these are the two types of fault is there in symmetrical fault. So in the first figure, ABC is actually representing the phases. Here we are representing with ABC. Somewhere you will find it UVW, somewhere you will find it RYB. But in India, a maximum country, they represent the phases with the color, and the color is in maximum in real life and in real field. They understand, they try to locate the phases with the color. First one, if it is red, then yellow, then blue. So here the LLG fault is actually happening in this section, this section, line to ground. Is the this type of this fault is called the line to ground fault. Line to ground fault. And LLL fault means if the fault in between three phases. So here ABC fault in between three faulted. So these two types of fault you can find for symmetrical faults, and it's occur infrequently. This line is very significant lines. You cannot find this type of fault frequently. That means it is infrequently. That means it is rare and called balanced fault. It is also balanced. Balanced means, can you remember in the last lecture of this subject, I show you that there are three phases is there: red phase, yellow phase, and blue phase. If the angle between three phases is 120 degree, if it is maintaining 120 degree apart from each other, this angle is 120 degree, this angle is 120 degree, this angle is 120 degree, then it is a balance system. So only it's a rare fault or infrequently this type of fault occurs in the system. So for that reason, you will find only 2 to 5% of system fault are symmetrical faults. Only 2 to 5%. Just remember this. If these faults occur, the system remains balanced but results in severe damage. This is the dangerous part to the electrical power system equipment. Remember the picture I showed you before 3-4 slides. So symmetrical fault is rare, but if it occurs, the system remains balanced but result in severe damage. So it's a dangerous situation will happen if symmetrical fault occurs. Where? In electrical power system. And the number is very significant. 2 to 5% of the fault are symmetrical faults. So in this way, it's overview only. There are so many things we have to calculate, we need to understand. There are many more things in these symmetrical faults. So I will talk about this in the next lectures. So the system engineer, the control engineer always try to maintain, protect this type of fault because its effect is not so good. Its effect is very dangerous and it can damage many more things, many more equipment, which is very harmful for the system. Now, unsymmetrical fault. Unsymmetrical fault are faults which leads unequal currents with unequal phase shifts in a three-phase system. Unequal current, unequal phase shifts means same thing. Suppose red phase, red phase, yellow phase, and blue phase. So here unequal current leads unequal. The current is unequal for these cases. Here also this is not equal to each other. So unequal current, unequal phase shift means 360-degree total angle, but this is not 120 degree. This angle is not 120 degree. This angle is not also, if we rotate like this angle is not 120 degree. So this is the problem. This is not 120, not 120, not 120. So it's the problem basically, the unsymmetrical fault for unsymmetrical fault, which leads unequal current with unequal phase shift in a three-phase system. So they are very common and less severe than symmetrical fault. So it is less severe and frequently it happens, less severe than symmetrical faults. There are mainly three types of, namely, first one is line to ground fault is represented by L-G, line to line fault that is L-L, and double line to ground faults that is LLG faults. So these are the three types of fault you can find in power system which is under unsymmetrical faults. So the first figure is representing the line to ground fault because there is a fault between line and ground. So R by B, three phase is there. Also for this case, two line, there is a fault between these two line, A to B, line to line fault. And this is number 3. If the fault is between two line and the ground, R and B phase, and this two phase is also connected with ground. If the fault is in between two line and ground, then it is called line to line fault. So these are the 3 types of fault, and less severe than symmetrical fault, and it does not maintain the same dual current, phase different. So 3 phase angle is not equal. So for that reason, it is called the unsymmetrical fault. Now, here the line to ground fault, LG, is the most common fault. Okay, so line to ground fault is the most common fault. That means 65 to 70% of the fault are the line to ground fault. 65 to 70%. This is very significant. Definitely will face this question in somewhere in your life, that which is the maximum number of fault in a system. That should be 65 to 70%. Next, it causes the conductor to make contact with the earth or ground. So 15 to 20% fault are double line to ground fault. Only 15 to 20% faults are double line to ground fault. So first position is holding by the line to ground fault. Next, second position is holding by the double line to ground fault. So obviously third position, and the range is from 5 to 10%. Now tell me who are responsible for this? The line to line fault. This fault, line to line faults occur when two conductors make contact with each other, mainly while swinging of lines due to winds. So what is the reason? Mainly swinging of lines due to winds. If no separator is connected between two conductors, you know what is separator? In the line, if you follow, you can find after some distance with some PVC pipe or some, with the help of some insulating material, there is a it is called the separator, is connected with in between two lines, so that when wind blow, it protect to touch to line. So it is actually the reason to avoid the line to line fault. So these are the percentage of fault occurring in our system, in the power system. So 65 to 70% fault, line to ground fault, 15 to 20% fault, the double line to ground fault, and the line to line fault occurs when two conductor contact, that is 5 to 10%. And the reason is wind. This is the main reason, the wind. Without this, there will be so many reasons, because when you enter in your professional field, if you work in a transmission distribution line, so new problem will come, and continuously new situation will occur, and you have to face different types of situation there. It is actually sometimes it does not match with the theory or which you are going to. So sometimes you have to take decisions for that. Sometimes what happen if the line length is very high, if you are working in a hilly area, so we need to the engineers or who are working on that field, suppose they are erecting a transmission line, so in some situation it is practically not possible to minimize the line length below 300 meter, 350 meters. So it's a long distance, and the facility of tower is not there. If tower is there, so problem you can reduce the problem. But if only the 10-meter pole, 9-meter pole is there, it's very difficult to um, erect a overhead line with the help of only 10-meter length steel tubular pole. So then what happened? The sagging will come, the line distance will increase. So airflow is, if a river is beside that area, so huge airflow will be there. So there is a chances for swinging of line due to this wind. So for that reason, you have to face the problem and you need to apply your general knowledge and you need to take some decision to avoid that type of faults. If you want, you obviously can do that. Now, causes of electrical faults. So there are many more reasons, but mainly we are focusing on first one is weather condition. Second one is equipment failures. Third one is human errors. Then smoke or fires. So normally these are the main reason. There are few reasons, but we are focusing on the main, and the weather condition means how this weather condition is uh, responsible for this electrical fault. Let's talk about that. It includes lightning strokes. You know what is lightning stroke? Yes, you all know about lightning strokes. It includes lightning strokes, heavy rainflow, heavy rainfall. Then what happened? Heavy winds. Okay, like Amphan. The wind is so much like any other cyclone or storm. It's not normal wind flow. The wind speed is more than 100 kilometers. So it's very difficult to control that situation on that time. Salt deposition position on overhead lines on the conductors. Snowfall area is very sensitive area, and ice accumulation on transmission lines, etc. So these environmental conditions interrupt the power supply and damage electrical insulation. For that reason, the weather has a vital role for the fault of the system. Now the next reason is the equipment failure. You know that various electrical equipment like generators, the motors, the transformers, the reactors, the switching devices, etc., causes short circuit faults due to malfunctioning, aging, insulation failures of cables, and windings. These failures result in high current to flow through the devices or equipment, which further damages it. So, which type of failure for this case? Equipment failures like generators, motors, transformers, reactors, switching devices, etc. causes short circuit faults. So these are the equipment sometimes causes due to why? What is the reason behind this? Malfunctioning, aging, insulation failure of cables, and winding. Okay, wrong winding sometime the reason, or if the winding is very old, then the failure may happen. Okay. Insulation failure of the cable. That means if the insulation fail anyhow, so fault may occur. This failure results in high current to flow through the devices or equipment, which further damage it. High current flow means high temperature, so that helps to burn the devices. Now let's about uh, talk about the human errors. Basically, human are controlling the system. In some country, their system is fully automated, but our system is not fully automated yet. Normally, the human beings are working there, the engineers, the laborers, the foremen, the supervisors. So when you are doing something, it's very natural some errors will be there. So electrical faults are also caused due to human errors, such as selecting improper rating of equipment or devices, forgetting metallic or electrical conducting parts after servicing or maintenance, switching the circuit while it is under servicing, etc. So it's a huge risky area also. Switching the circuit while it is under servicing. Just imagine if this situation happen, what will be the situation? Maybe sometime death is there. So human error has a great role to avoid this type of problem. To avoid the human errors now some new it's not new, but some special devices. The lifeline detector is also used in the system to avoid the human errors. Like when some transformer fault is there, the engineers, after disconnecting from the substation or from the distribution station, suppose the line isolate from their control panel, but the charging current stay inside the cable. So after discharging that current with the help of the earth stick, sometime if directly the worker touch the cable, there is a chance for huge damage, because sometimes the charging current stay in the cable. So for that reason, after discharging with the help of earth stick, the engineers use the lifeline detector. If there is any current on that cable, the charging current, the detector indicate, give some signal that there is some current. Again, the discharge. So nowadays, in maximum places, the devices are used to avoid the human error. So human error is one of the reasons for these electrical faults. The next one is the smoke of fires. Ionization of air due to smoke particles surrounding the overhead lines results in spark between the lines or between conductors to the insulator. This flashover causes insulators to lose their insulating capacity due to high voltage. So this is one of the reasons for this fault. It happens. So we have to realize all these things, that how this fault is happening and what is the way to solve this type of fault. So today I'm just ending my lecture here. To make this video lecture, I take help from this website and the book A Principle of Power System by V.K. Mehta and Rohit Mehta. Thank you all for watching the lecture. For any confusion, you can mail me or directly contact with me. Have a nice day.